question number 3. So whenever possible, if you find when you look at these diagrams, if you feel like you don't understand, try to draw it. Okay, I mean, in case, because like whenever you see a question, it is very difficult. Like even like, have you noticed, you are speaking to someone, he is telling, and you are also nodding the head, right? You keep on nodding, and finally after a few minutes, like what you are speaking, I cannot even remember, right? So likewise, this one also, you will keep on looking at the diagram, but after a few minutes you will be like, what I was thinking, like. So always it is better to draw the diagram. Whenever you see such a diagram, just try to draw it. Like if you don't see a thread, so always try to draw it. It will be much helpful. Okay. So here there are two chords. So there are two chords, AB and CD, and there's the center. Okay, and it is given, this is perpendicular. Okay, so now we are supposed to show that OP is, this is P and this is O. So now you need to show that OP equal to OQ. OP is equal to OQ. This is Q. Okay, so how to show that?
Using congruence.
I'm sorry?
Using congruency.
Yeah, using congruency. You can consider the triangles OAP and OCQ. Okay? So if you consider the triangles OAP and OCQ. Why did I take OAP and OCQ? Because I am supposed to show that OP and OQ, right? So best way to show that two sides are equal is, like, the congruency is, so I hope you can remember the congruency laws and everything. So you have this OA and OC. What can you say? Both of them are radius. So this length is going to be, yes, this length is going to be equal to this length. Then this angle is 90 degrees. Okay? Then what else you can say? The theorem. Yes. The theorem you just learnt. The perpendicular from center to the chord is will bisect this chord, right? So this length is going to be equal to this length. So then this length is going to be equal to this length. Then it is given, this length is going to be equal to this length, right? So this will be the midpoint, right? But in the question it is given AB and CD are equal chords. AB and CD are equal chords, right? That means the length of this one is equal to length of this one. So this will be half of this one. This will be half of this one. So obviously AP is going to be equal to CQ. So you can write AP equal to CQ. AP equal to CQ. Then you can write AO equal to CO. AO equal to COY, radius. And the angle is 90 degrees. Angle OPA equal to angle OQC. OQC equal to 90 degrees. Okay, it is given. So you can write these two triangles are congruent to each other. So you can say APO is congruent to OCQ triangle. Therefore, you can say OP is equal to OQ.
We should put the case, no, under the case.
Yeah.
SAS.
SA.
No, RHS.
Yeah, right hand hypotenuse side, right? So if you are using SAS, the angle should be in between, right? So if this is side, the angle should be in between the two sides. If you are using SAS case, but in this case it is not. It is different. The angle, this angle is equal to this angle, but the two sides are not in between the two. The angle is not in between the two sides. So you cannot use SAS. You have to use RHS. Right hand, right angle.
The case is RH.